Hello, and welcome back to my series on building a web server from scratch in C. And this video is going to be a bit different from the previous ones because today I have done a lot of work off camera and I want to show you what I've been doing as well as show you what I need to do next. So things are becoming more complicated in this web server and it's becoming a bit repetitive at times, so I don't want to subject you to having to watch me do the same things over and over. So I am just showing you what I did here, and I'll teach you about how it works. Largely, if you watched the previous video on parsing out the request line, then you'll be able to understand what's happening, or I'm sorry, when parsing out the header fields. So I used to have this constructor, and in it I was parsing out the request line, the header fields, and the body all in the one function, and I ended saying that that was getting kind of messy. And so what I did was create additional functions to parse out each section individually. And essentially what this does is just create dictionaries out of the string that was passed in. And if we look at the .h file, you can see that I have removed a number of parameters from this HTTP request and instead decided to just put a dictionary for the request line, header fields, and body. That made it a bit easier to work with these strings just because of the way that they need to go together. It made this a little bit more repeatable. So I have done that, and largely this is all exactly the same. This is the wrong file. So all it does is it creates a copy of that field that we pass in, the header string, the request line, whatever it is that we pass into each of these functions. And so it creates a local copy of that and then extracts each element from it. And it does this by creating a queue. It then passes every single line individually into the queue, and then we pull each line back out and separate it into key value pairs or whatever else we need it to be separated into. And there are a few things that were happening here that I want to point out to you. One is with this insert method. So I was having some, not difficulties, but strange results when I did this in different ways. So if I passed in right here, for example, if I passed in the size of method, then when I pulled it back out, it would have additional random characters, or it would have too few characters. It would not be exactly what was passed in originally. And so I found that when I use this size of function to insert things into the dictionary or search for things in the dictionary, I need to specify that it is the size of a character array with the number of elements that is equal to the length of whatever string I'm trying to insert. That seems kind of strange to me. I don't know why it's behaving that way, but the results were what they were. So when I do it like this, it seems to work. If you have an idea of what's going on there, please do let me know. I would like to understand that a little more thoroughly. So essentially what this does is just create a bunch of dictionaries out of the parameters. And here you can see that I'm starting in on the next bit, and that's where this is becoming more complicated. So depending on the kind of request I get, and depending on the values that are stored in those header fields, I need the server to behave differently. So for example, a GET request doesn't really come with a body. So you can put a body in a GET request, but it doesn't really do anything for you. Typically, the variables of a GET request are stored in the URL itself. So if we look at my object here, not that one, but this one. Nope, not that one either. This one. My object here, I have a dictionary for the body, but in a GET request where there are parameters in the URL, I actually need those parameters to be put into the body rather than whatever the body is. So that's just one example of the numerous ways I need this thing to react to different HTTP requests. Think about the different types of headers that we can see. If I pull up a list, then we can see that there are a number of them. Let's see. I found a list the other day, and there was, yeah, you can just see that there are numerous different types of headers that I can get. And I need to have my server react in different ways. One example is, I don't remember exactly the wording for this. It was sort of the opposite of content type, which is the content type that the client is sending me, but it was like accepts or something along those lines. And that is what kind of content it's wanting back from me. So does it want a JSON? Does it want HTML? Does it want plain text? So I need my server to react to those different things. And that becomes really complicated and somewhat repetitive. So it doesn't make for really great videos, which is unfortunate. But we will work with that as we go. And I think the plan now is to think about a minimum viable product. So what do I absolutely need in order to start using this? And what can I say can be made later? So there are some header fields and some methods that you would make an HTTP request, such as head, for example. I don't necessarily need to implement functionality for a head request or a put request or a delete request right now. Eventually, I will want those in there, but in order to host the website that I want to host, I don't need that right away. So I'll probably move forward trying to get it so that it basically works and that I can host my website on it. Once I do that, I can start building on top of it and just adding more functionality kind of as I need it, just like the library itself. Okay, so in that spirit, I created a new object called an HTTP server. And something I want to point out here is that these request lines or these request headers, whatever you want to call them, I find strangely formatted. You can have variables in the URL, or you might have variables in the body. You'll have some variable number of header fields, and the header fields are separated from the body by a double space, but the request line is not separated from the header fields by a double space. I am so far unimpressed with the formatting of HTTP requests, and I just want to point out that what I am trying to make right now is an HTTP server. So I have to deal with that. But you don't necessarily need to make an HTTP server. This server here, this more basic server object, it could take anything. It does not need to be formatted in this HTTP request line format. I can make it so that these servers and clients just send JSON objects back and forth, and I can cut out all of this request line parsing altogether. I could also invent my own protocol of what these things are going to be sending to each other. So in the future, when I make different servers and I am applying them to different tasks, I am probably not going to want to use HTTP. The reason I'm using HTTP right now is because I'm making a website, and you are going to be accessing this website through a browser, which is going to send HTTP requests. So I'm kind of constrained by that at the moment. But in the future, I'm planning to make some devices of my own that are going to be working as networks. And I want these devices to communicate with each other. And in that circumstance, I am free to have them communicate in any manner that I see fit. So I just wanted to throw that out there. And let me show you what is kind of happening with this HTTP server itself. So this is very similar to the launch sequence that I defined earlier for a more basic server. Essentially, I just print a line that says waiting. We wait for a new socket. We create a buffer for storing whatever the client requests from us. We then read what the client requests. And then I call the constructor for the HTTP request. That way I can parse out the request into all of these different dictionaries to make the data more manageable. And these I have commented out because originally I was just having it give some generic response. So here I'll show you that what I was trying to do was have it print back the client's IP address. So I specified that I wanted a field called host, and this was going to be a header line or a header field. And so this variable is called content type. That's from a previous iteration. But what I do is in the request object, I specify I want the header fields dictionary. I'm getting a text message. I then specify, red hat. All right, anyway. I then specify in the header fields dictionary, I want to search for something, and I pass it in the reference to that header fields dictionary. I say I want to search for host, and I want to have it the size of host, which I have to again do with the size of a character array of the string length of X. Bit odd. And then basically I just take that result, paste on a HTTP header, and write it back to the client. And that was working well. In fact, the host actually refers to the server, not the client. So it was always sending back the server's IP address, which that's amusing, but I just misunderstood what that was going for. But it worked. I would get these different IP addresses depending on how I used it. So that worked great. And so all of the components in the request line were being parsed out into their respective dictionaries. They were actually becoming useful. And now we can start doing more interesting things. One of which is going to be something like this. So I created this retrieve page function. And this is sort of that most or minimum viable product philosophy that I was going for. This function is a prototype for selecting a page to show the user. So, for example, what happens is you pass in the request object and the integer for the address of new socket, so the client that's asking for it. And then what you do is you ask in the request, we are going to go to that request line dictionary and we're going to search it. We're going to pass in the reference to that dictionary, and we're going to search it for URI. And what we want is to get the URL the user is looking for. So if they typed in homodeus.us/users, then the URI in this case is going to be /users. And so we are going to try and find what they asked for. If it was just homodeus.us, that would just be a slash. And what we want to do is associate that with a file on our hard drive. So we find that URI, but remember that in a GET request, the variables will be in the URL itself, and the separator is a question mark. So I use our string token function to split that result on the question mark, saving the URL as the first result, and then another variable called vars to the remainder of it. And I will need to actually parse vars out into a dictionary later, but I'm not doing that just yet. I then create this in the path variable. I've already created it. I'm going to specify the path to the root directory of my server. And for now, I'm just saying users Eric desktop because I can put files on my desktop pretty easily, and that's no problem. But later on, it will have a more specialized use, and I'm thinking I'll need a configuration file for that. So what I do is now I just have a conditional that sees what is the user asking for. At the moment, there are only two possible options. They are either going to ask for /test or just slash. If they ask for /test, we are going to paste in the URL, itself into this path. Otherwise, we are going to paste in /index to that. So I'm going to create an index.html file. I then have to specify .html on the end. And that is because the user is not going to have to type in .html themselves. They just type in homodeus/test or .us/test. And I need to say that that refers to test.html. So we specify that that's the file that we want, and then we open that file, and this whole thing is just going to read the entire contents of that file, and this continues that section. And then what we're going to do is create a response character array. We're going to put in a status line, And then we are going to put in the contents of our file and then write it back to the client. Okay, now there's a lot in there that is actually worth going through and coding with you, but this is just a prototype. I am not actually going to use this. This is just so I can test things. So I wanted to show you what's going on here so that you actually see that it's working, but this is not the way I'm going to do it in the future. I have a more robust plan in mind for that. So don't worry too much about this. We're going to do something much more elegant in the future. So what we have is, well, if I am on my desktop and I say cat test.html, we can see that I have an HTML document called test. And if I copy this, and let's touch index.html, so we're going to create that, and nano paste everything in. And let's change this so it says, okay, so index is second and test is first. So now if I actually run the server, I created this little test file here, so we can run it. We see that it's waiting. And then back over in my browser, I can do 1.27 or 127.0.0.1. That's just the loopback address for my machine. And if I go there, you see I get my second heading and my second paragraph. And this is interesting. This is what I mean with the lengths of strings. So here I'm getting some extra nonsensical characters. And I believe the reason is that I didn't copy and paste all of this over. Something strange is going on with these characters arrays and going beyond it or not far enough in it. So I have a little more work to do there. But the important functionality to show you is that now if I type in /test, I'll get a different web page. So my web server is now capable of serving different web pages depending on what the user is asking for. And that's on the right track. We need a much more elegant way to do this though. And what I'm thinking is that the end goal for this server is something like Flask for Python. So if you've never used Flask, let's create a file. So in Flask with Python, you will type in something such as, so at app.route, and then something like, well, you'll pass in the actual URL, so /test, and then methods equals post, or whatever you do there. Then you'll say def test, and then you'll put in a bunch of code, and then you will return render template test.html. And this format will do a lot of work for you. So you just specify what the web address is, what methods it accepts, what it needs to do, and then what it needs to send the user. And I've always found working with this to be really elegant. I've always really liked Flask. And what I'm thinking is that the end goal for this web server is eventually going to be a Flask-like interface completely in C. So you will basically just need to define some routes and then what they do and what they return, and it will do the rest for you magically. Not very magically, but that's kind of the end goal here, I'm thinking. If you have any suggestions about that, please let me know. I'm definitely open to comments there. But rather than in the case of Flask, where you would need to run Flask on top of Apache to have a production server, I want to have them merged together so that you have a production server right out of the gate, but you have a simple way of interfacing with it and specifying what you want it to do. So that's the plan right now. And the next step for me is going to be to do a little more work on this HTTP server. So there are some things in this launch sequence that are probably going to be common to every HTTP server. We're going to have something that accepts the connection. We're going to have something that handles that connection and then responds to that connection. And also there are going to be some things that I will want to do to sort of put all of that together. So for example, if I want my interface like this, I will need an additional function and data structure for storing all of these functions along with a name in order to know what to do with them. So think about a binary search tree, for instance, where the key is our URL and the data is actually a function pointer rather than a data pointer. So I'll have to do some experiments with that, but that is the plan. I'm sorry there wasn't a whole lot of coding in this episode, but I needed to show you what I have actually been doing before I start doing other things. And in the future, when I start actually making these sequences, that is more original stuff and not me just parsing yet another string, I will definitely show that on video. So that will do it for this video, and I hope you enjoyed it. If you did, like, subscribe, and all of that, and I will see you next time. Toodaloo.